Okay, today's lesson is calculating enthalpy of reaction using delta H of formation and delta H of combustion. So just to recap, delta H of formation is when 1 mole is formed from its elements under standard conditions, and that can be negative or positive, so it's enthalpy change. Recall that we did an example for the formation of ammonium chloride. So it's nitrogen plus hydrogen plus chlorine to give you an ammonium chloride is when 1 mole is formed from its elements, and that's delta HF. Delta H of combustion is delta HC, is when 1 mole reacts with oxygen to give you carbon dioxide and H2O, and that is an exothermic reaction. So formation, 1 mole is formed, so that means you have 1 mole of product, and for combustion you have 1 mole of reactant. Okay, so those two terms, how do we use those to calculate the enthalpy change for a reaction? So a few things to recap. The enthalpy of formation for an element in its standard state or on the periodic table basically is equal to 0. So remember, those elements cannot be formed, so delta HF is 0. So if I ask for delta HF for sodium, it's going to be 0. Remember the Hofbrinker family, they are diatomic, so they are H2, N2, O2, and so forth. So please don't forget that delta HF is 0. So you might not be given that information on a question. Always remember, for an element it is 0. How do we use the delta HF to form the heat to calculate the enthalpy for a reaction? Delta H of the reaction is the sum of the enthalpy of the reaction for the products minus the sum of the enthalpy of the reaction heat of formation for reactants. So that's the definition in words. In the equation, delta H for the reaction is equal to delta HF, the sum of all the delta H for all the products minus the sum of all the delta HF for all the reactants. So in short, delta H for the reaction is products minus reactants. The reaction, however, can be specific. So I could ask you to find the delta HX for neutralization. Then you'd need to find all the delta HFs for all the products and the reactants, and then you do products minus reactants. The coefficients in the balance equations are important, so we have to make sure our equations are always balanced. And we'll see what that means in a while. Now this example says calculate the standard enthalpy of reaction for the oxidation of ammonia gas to nitrogen dioxide gas and water vapor given the following standard enthalpy or heats of formation. This question, you were not given the equation for the delta H of reaction, but you weren't given the balance equation, so you have to write the equation and balance it. But you're given a delta HF for all the reactants and the products that they were given. So the first thing that you need to do is to write the balanced equation. Okay, so it's 2 NH3 gas plus oxygen 7/2 to give you 2 NO2 gas plus 3 H2O. And that is what we want to find, the delta H for the reaction for that particular equation. So if we look at the equation, we have the reactants, remember, always on the left hand side. The arrow means that the reactants yield to give you the products, and the products are on the right hand side. Delta H for the reaction is equal to products minus reactant. I'm going to do it the long way so that you guys can go through it. When you have mastered it, there's no need to write out the products and the reactants. You can go ahead and do the question. So the products we have are nitrogen dioxide and H2O. We have 2 moles of nitrogen dioxide, so it's 2 times 34, so that gives us 68 kilojoules per mole. We have 3 moles of H2O, so that gives us 3 times minus 242, so that's minus 776 kilojoules per mole. We add those two, we get minus 658 kilojoules per mole, and that's the total amount for our products. Then we have our reactants. We have ammonia. We have 2 moles of ammonia, and we have oxygen. Now we're using the values that were given above. If you recall, it's for ammonia it's minus 46, so it's 2 times minus 46, that gives us 92 kilojoules per mole. Oxygen, although it was given in the question this time that delta HF is 0, it is not always given. So oxygen is equal to 0 When you add both up, you get minus 92 kilojoules per mole. The delta H for the reaction is then going to be equal to products minus reactant. The products were minus 658 minus, and the reactant was minus 92, so minus 658 plus 92 will give you 566 kilojoules per mole. Okay. In summary, remember to find the delta HX for the reaction, delta HF, delta H for the reaction is equal to the sum of the delta HF of the products minus the sum of the delta HF for the reactants. Some things to remember. Remember that coefficients are very important. In the equation, we have to make sure the equation is balanced properly, because we have to multiply the delta HFs by the coefficients to get the correct value. Elements have a delta HF of 0, don't forget that. And because this is an equation just like any mathematical equation, delta HX is not always going to be asked. You can be given delta HX and asked to find delta HF for any one of the reactants or the products. So let's get to another question. Return to your worksheets, and the last set of questions, and then work on question 1.